Let's come to chapter number 11, that is light. You might have seen a beam of sunlight when it enters a room, though a narrow opening or a hole. You may have also seen beam of light from the headlamps of a scooter, car, and engine of train. Figure 11.1. Similarly, a beam of light can be seen from a torch. Some of may have seen a beam of searchlight for a lighthouse or from an airport. What do these experiences suggest? Light travels along a straight line. Bujo recalled an activity he performed in class 6. In that activity, he looked at a candle, lighting candle first through a straight pipe and then through a bent pipe. While he was Buju not able to see the candle flame through a bent pipe. This activity showed that light travel along a straight line. How can we change the path of light? Do you know what happened when the light fall on a polished or a shining surface? Reflection of light. One way to change the direction of light is to let it fall on a shiny surface. For example, a shining stainless steel plate or a shining steel spoon can change the direction of light. The surface of water can also act like a mirror and change the path of the light. Have you ever seen the reflection of a tree or building in water? Any polished or a shiny surface can act as a mirror. What happens when the light falls on a mirror? You have learned in class 6 that a mirror changes the direction of light that falls on it. This change of direction by a mirror is called reflection of light. Can you recall the activity in which you got the light of a torch reflected from a mirror? Let us perform a similar activity. Activity 11.1. Take a torch, cover it with glass, cover its glass with a chart paper and which has three narrow slits as shown in figure 11.5. Spread a sheet of Paheli remember the story of the lion and the rabbit from the Panchtantra, in which the rabbit fooled the lion by showing him his reflection in water. Chart paper on a smooth wooden board. Fix a plain mirror strip vertically on the chart paper, figure 11.5. Now the direction beam of light on the mirror from the torch with slit. Place the torch in such a way that its light is seen along the chart paper on the board. Now adjust its position so that the light from torch strikes the plain mirror at an angle. Does the mirror change the direction of light that fall on it? Now move the torch slightly to either side. Do you find any change in the direction of the reflected light? Paheli wants to know what makes things visible to us. Bujwa thinks that the object is visible only when the light reflected from them reach our eyes. Do you agree with him? Look into the mirror along the direction of the reflected light. Do you see the slit in the mirror? This is the image of slits. This activity shows how the light gets reflected from plane mirror. Let us play around with the image formed in the mirror and know a little more about them. Activity 11.2. Caution. Handle the light candle with care. It's better if this activity is performed in the presence of teacher or an elder person. Place a light candle in front of plain mirror. Try to see the flame of the candle in the mirror. It appears as if similar is placed behind the mirror. The candle which appears behind the mirror is the image of the candle formed by the mirror. The candle itself is the object. Now move the candle to different position in front of the mirror. Observe the image in each. Buju noted in his notebook. He not surprising that my image of the same as my whether the mirror is in. Buju noted in his notebook. Is it not surprising that my image is of the same size as me, whether the mirror is small or large? Was the image upright in each case? Did the flame appear on the top of the candle as its object? Such an image is called erect. An image is formed by a plane mirror is erect and of the same size as the object. Now place a vertical screen behind the mirror. Try to obtain the image of the candle on this screen. Can you get the image of the screen? Now place the screen in front of the mirror. Can you get the image on the screen now? You will find that the image of the candle cannot be obtained on the screen in either case. What about the distance of the image from the mirror? Let us perform another activity. Activity 11.3. Take a chessboard. If a chessboard is not available, draw a chart paper 64, 8 into 8 square of equal size. Draw a uh, draw a thick line in the middle of the paper. Fix a plane mirror vertically on this plane. Place any small object such as pencil, sharpener, and at the boundary of the third square counting from the mirror. Note the position of the image. Now shift the object to the boundary of the fourth square. Again, note the position of the image. Did you find any relation between the distance of the image from the mirror and that of the object in front of it? You will find that the image is at the same distance behind the mirror as the object is in front of it. Now verify this is by placing the object anywhere on the chart paper. Paheli made a note in her notebook in a plain mirror, the image is formed behind the mirror. It is erect as the same size and it is the same distance from the mirror as object is in front of it or left. When we see our image in a plain mirror, it is exactly like you. Have you ever noticed that there is one interesting difference between you and your image in mirror? Let's find out. Activity 11.4. Stand in front of plane mirror and look at your image. Raise your left hand. Which hand does your image raise? Now touch your right ear. Which ear does your hand touch in your image? Observe carefully. You will find that in the mirror the right appear left and the left appear right. Now that only sides are interchanged, the image does not appear upside down. Write down your name on a piece of paper and hold it in front of plane mirror. How does it appear in the mirror? Buju saw an ambulance on the road. He was surprised to use the word ambulance in front of was written in a strange manner. Can you now understand why the word ambulance is written as in figure 11.1? This vehicle ahead of ambulance look like is her or his rear view mirror, and she or he can read ambulance written on it and give it to the way. It is the duty of every one of us to allow an ambulance to pass without blocking its way. You might have observed that in the side mirror of a scooty or a car, the image of all the objects appear smaller than the object is themselves. Have you ever wondered why it is so? Playing with a spherical mirror. Saheli and Buju were waiting for their dinner. Buju lifted a stainless steel plate and saw his image in front in it. Oh, this plate acts as a plane mirror. My image is erect and is of the same size. Saheli saw her image using the back of a steel spoon. Buju, look here. I can also see my erect image, though it is very small in size. This spoon also acts as a mirror of the some kind, said Paheli. You can also use a spoon or any curved shining surface to see your image. Activity 11.5. Take a stainless steel spoon, bring the outer side of the spoon near your face and look into it. Do you see your image in it? Is this image different from what you see in the plane mirror? Is this image erect? Is the size of the image is small, same, or large? Now look at your image using the inner side of the spoon. This time, you may find that your image is erect and large in size. If you increase the distance of the spoon from your face, you may see your image inverted. You can also compare the image of your pen or pencil instead of your face. The curved shining surface of a spoon acts as a mirror. The most common example of curved mirror is a spherical mirror. If the reflecting surface of a spherical mirror is concave, it is called concave mirror. If the reflecting surface is convex, then it is called convex. Why are concave and convex mirror called spherical mirror? Take a rubber ball and cut a portion of it with a knife or a hacksaw blade. Be careful, ask an elder person to help you cutting the ball. The inner surface of the cut ball is called concave and the outer surface is called convex. The inner surface of a spoon act like a concave mirror, while its outer surface act like convex mirror. We know that the image of an object formed by plane mirror cannot be obtained on skin. Let us investigate. It is also true for the image formed by a concave mirror. Activity 11.6. Caution. You will conduct activity 11.6 in sunlight. Be careful, never look directly towards the sun or its image as it may damage your eyes. You may look at the image of the sun when it is thrown on the screen or a wall. Take a concave mirror, hold it facing the sun. Try to get the light reflected by the mirror on a sheet of a paper. Adjust the distance of the paper until you will get a sharp bright spot on it. Hold the mirror and the sheet of the paper steady for a few minutes. Thus the paper start burning. This bright spot is in fact the image of the sun. Notice that this image is formed on the screen. An image formed on a screen is called real image. Recall that this activity 11.2 image formed by a plane mirror could not obtain on screen. Such an image is called virtual image. Now let us try to obtain on this screen the image of a candle flame formed by a concave mirror. Activity 11.7. Fix a concave mirror on a stand or any arrangement to keep the mirror steady would do and place it on a table. Paste a piece of paper, white paper on the cardboard sheet, say about 15 centimeter into 10 centimeter. This will act as a screen. Keep a lighted candle on the table at a distance of about 50 centimeter from the mirror. Try to obtain the image of the flame on the screen. For this, move the screen till a sharp image of the flame is obtained. Make sure that the screen does not obstruct the light from the candle falling on the mirror. Is this image real or virtual? It is on the same size as the flame. Now move the candle towards the mirror and place it on a different place from different distance from it. In each case, try to obtain the image on the screen. Record your observation in table 11.1. It is possible to obtain the image on the screen when the candle is too close to the mirror. We see that the image formed by a concave mirror can be smaller or larger in the size than the object. The image may be real or virtual. Concave mirrors are used for many purposes. You might have seen doctor using concave mirror for examining eye, ears, nose, and throat. Concave mirrors are also used by dentists to see a large image of the teeth. The reflector of a torch, headlight, or of car and scooter are concave in shape. Bujo observed his image in the shiny surface of the bell on his new bicycle. He found that his image was erect and small in size. He wondered if the bell is also a kind of spherical mirror. Can you recognize this type of mirror? Note that the reflective surface of the bell is convex. Activity 11.8. Repeat activity 11.7 now with a convex mirror in place of concave mirror. Record your observation in table similar to the table. Could you get a real image at any distance of the object from the convex mirror? Did you get an image larger than the object? Can you now recognize the mirror as side mirror in automobiles? These are convex mirror. Convex mirror can form the image of the object spread over large area. So these help the drivers to see the traffic behind them. Image formed by lenses. You might have seen a magnifying image. It is used to read a very small print. You might have also used it to observe the body parts of a cockroach or an earthworm. The magnifying glass is actually a type of lens. Lenses are widely used in spectacles, telescopes, and microscopes. Try to add a few more use of lenses to this list. Get some lenses, touch and feel them. Can you find some difference just by touching? Those lenses which feel thicker in the middle than the edge of or convex lens. Those which feel thinner in the middle than at the edge or concave lens. Notice that the lenses are transparent and the light can pass through them. Let us play with lens. Caution. It is dangerous to look through a lens at the sun or a bright light. You should also be careful not to focus sunlight with a convex lens or any part of your body. Activity 11.9. Take a convex lens and magnifying glass, put it in the path of the sun ray, place a sheet of paper as shown, adjust the distance between the lenses and the paper till you get a bright spot on the paper. Hold the lens and the paper in this position for a few minutes as the paper begins to burn. Now replace the convex lens with a concave lens. Do you see a bright spot on the paper of this time too? Why are you not getting a bright spot on this time? You have seen in the case of mirror that a different position of the object, the nature and the size of image change. It is true for lens also. Let's find out. Activity 11.10. Take a convex lens and fix it on a stand. As you did the concave mirror, place it on a table. Place a lighted candle at a distance of about 50 centimeters from the lens. Try to obtain the image of the candle on a paper screen placed on the other side of the lens. You may have to move the screen towards or away from the lens to get a sharp image of the flame. What kind of image did you get? Is this real or virtual? Now vary the distance of the candle from the lens. Try to obtain the image of the candle flame every time on the paper screen by moving it. Record your observation as you did in activity 11.7 for a concave mirror. It means that we have seen the image formed by the lens from the side opposite to the that of the a convex lens converging bends toward inward. The light generally fall on it. Therefore, it is called converging lens. On the other hand, concave diverge bends outward the light and is called a diverging lens. Did you get in any position of the object and image which are erect and magnified? Could this image obtain on a screen? Is the image or real or virtual? This is how a convex is used in magnifying glass. In a similar fashion, study the image formed by a concave lens. You will find that the image formed by a concave lens is always virtual, erect, and small in size than the object. Sunlight, white or colored. Have you ever seen a rainbow in the sky? You might have noticed that it appears usually after the rain when the sun is in the sun in the lowest. The rainbow is seen as a large arc in the sky with many colors. How many colors are there present in a rainbow? When observed carefully, there are 7 colors in rainbow. Though it may not be easy to distinguish all them, these are red, orange, yellow, green, blue, indigo, and violet. Does this mean that the white light consists of 7 colors? You might have seen that when blow soap bubbles, they appear colorful. Similarly, when light is reflected from the surface of compact disc, you see many colors. On the basis of this experiment, could you we say that the sunlight is mixture of different colors? Let us invest. Activity 11.11. Take a glass prism. Allow a narrow beam of sunlight through a small pore in the window of dark room to fall on one face of the prism. Let the light coming out of the outer surface of the prism fall on. Paheli wants to tell you that you can see a rainbow only when your back is towards the sun. A white sheet of paper or on a white wall, what do you observe? Do you see colors similar to those in rainbow? They show that the sunlight consists of 7 colors. The sunlight is said to be white light. This means that the white light consists of 7 colors. Try to identify these colors and write their name in your notebook. Can we mix these colors to get white light? Let's try out. Activity 11.12. Take a circular cardboard disc of about 10 centimeter diameter. Divide this disc into 7 segments. Paint the 7 rainbow color on these segments as shown in figure. You can also paste color Also paste colored paper on these segments. Make a small hole at the center of the disc. Fix the disc loosely on the tip of a refill of a ball pen. Ball pen. Ensure that the disc rotates freely. Rotate the disc into daylight. When the disc is rotate fast, the color gets mixed together and the disc appear to be whitish. Such a disc is properly known as Newton disc. Now come to the last part of the chapter, that is summary. Light travel along a straight line. Any polished or shining surface act as mirror. An image which can be obtained on screen is called real image. An image which cannot be obtained on screen is called virtual image. The image formed by plane mirror is erect. It is virtual and is of same size as the object. The image is at the same distance behind the mirror as the object is in front of it. In an image formed by a mirror, the left side of the object is seen on the right side of the image, and the right side of the object appear to be on the left side in the image. A concave mirror can be form a real inverted image. When the object in a place very close to the mirror, the image formed is virtual, erect, and magnified. Image formed by convex mirror is erect, virtual, and smaller in size than object. A convex lens can be form real and inverted image. When the object is placed very close to the lens, the image form is virtual, erect, and magnified. When used to see object magnified, the convex lens is called magnifying lens. A concave lens is always erect, virtual, and smaller image than object. White light is composed of 7 colors. Do you know the mirror can be used as weapon? Archimedes, a Greek scientist, is said to have done just that more than 2000 years ago when the Roman attacked Syracuse, Syracuse, a coastal state in Greece. Archimedes used mirror arranged shown in figure. The mirror could be moved in any direction. They were positioned such that they reflected the sunlight on the Roman soldier. The soldier was dazzled by the sunlight. They did not know what was happening. They got confused and ran away. This was an example of triumph of ideas over military might. This is the way where Archimedes used his principle.